Hello everyone, in this video I am going to teach you the difference between array and linked list data structure, and also I will teach you which is best data structure to use, array or linked list. Let's see. Now we can't say within a single property that which is best, array or linked list. We can't say within one thing because it depends on various parameters. You can't decide within one parameter. Let's see various parameter and which is best according to these parameters. Let's see. Now first parameter is accessing an element. What does mean by accessing an element? Accessing an element means you want to find an element present in particular index. You are given an index and you should find the element present in that index. Now see. Let's see for that on array. Accessing on array. Let's see. Now I am creating an array of size 5. 1, 2, 3, 4, 5. Now let's say the index are 0, 1, 2, 3, 4. Now I am storing 5 integer values in this array. Let's say 4, 8, 3, 5, 7. Now see. Now you want to access an element present at index 2. So index is 2 here. What is the element present at here? 3. So it should return 3. What is the time complexity for this accessing an element in array? It takes O of 1. O of 1 means it takes single constant time. Within one step you can get. Whereas in linked list it takes O of n. That means in this no need to travel all the elements present in the array. You can you can find the element present in that index within single time. But for linked list you should travel all the nodes in that linked list. Let's see how. See, suppose in this you want to find the element present at index 2. Now suppose you have given the base address. You know the base address, that is 100. 0th index address is 100, let's say. Now you want to find the address of index 2 because you want to find an element present at index 2. So you should find the address of index 2. How to find? See, address of index 2 is, formula is base address plus index into size. What does this I'll say? See, now you know the base address. Base address is 100. So 100 plus index. Index is which address of which index you want to find? Index 2. Address of index 2 you should find. So index is 2. Now into size. Size is what? Size is the size of each data type in this. Data type in this array is what? Integer values. You are storing integer values. So integer takes 4 bytes. So I am writing into 4 because each integer takes 4 bytes. So 2 into 4. Now see, 100 plus 2 into 4. 2 into 4 is 8. So 100 plus 8 is 108. So you can find the address of second index is 108. Now if you see each integer takes 4 bytes, right? So see, 100, then 104, then 108, then 112, then 116. You have found the address of index 2 within using this formula within single step. So it takes time complexity O of 1. Let's see for linked list. Suppose I am creating a linked list of size 5. Suppose this is first node, then this is second node, then this is third node, then this is fourth node, then this is fifth node. Let's say, see. Now I am storing suppose 5 elements in this array. Let's say 4, 8, 3, 5, 7. Same numbers 4, 8, 3, 5, 7. Now let's say the address of this is 100. Then this is 200. Then this is 300. Then this is 400. Then this is 500. For example, I am saying these are the address. Now see. Now this is pointer part. This stores the address of second node. 200 is the address of second node. So I am storing here. Then this is 300, so 300 I am storing here. Now here 400 gets stored because address is 400 in next node. Then here 500 gets stored. Then here 0 because no node is there present in next. Now see, suppose you want to find the address of second index you found in array. Same second index you want to find the element present at second index. This index, the element is 3. How you should find? For this, the index are continuous. Continuous means what? The addresses are continuous, 100, then 104, 108 in sequential manner it's there. But in this I have written in sequential manner in equal intervals, but it's not equal intervals because in linked list it's not continuous. Here 100 may be there, here 400 may be there, the address, here 700, like that. It can be not be in equal interval. So for you can't calculate by using formula. So how to find the element present at second index? This second index, you should take a temp pointer, and see, suppose this is head. What is head? Head is a pointer which stores the address of first node. To find which is first node, the address of first node is 100, so 100 gets stored over here. Now temp points towards this 100 first node. Now see, now you have to find the element present at index 2, means this is index 2, this is 0, this is 1, this is 2. If you want to find, means you should first place temp equals to head, then after that you should move temp value to temp equals to temp next. Temp next is what? This thing, 200. So temp value changes to 200. Now again temp equals to temp next. Now it's 200, right? Now again temp equals to temp next, means temp is this now. Temp next is 300. 300 means it's over here. So it points over here. Now the value changes to 300. The address is 300. So now temp is 300. Now the index is 2. Now you want to print the temp data. Data is this data value. So now you get 3. So for this you should travel from first index, from starting from head till that n. If suppose you want to find the element present at last index, means you want to travel whole linked list, all the nodes. So this takes O of n, whereas array takes O of 1. So if you see, now if you want to frequently access an element, suppose you want to you want to access an element many times, then you can use array because it takes constant time. So this is first property. Now see, next is memory utilization. Memory utilization means what? See, suppose let's say, see, I have created suppose array of size 5. Now I have for creating, what I should do? I should declare the array of size 5. So a of 5. If I write like this, I will create an empty array of size 5. Now see, I have 5 empty spaces, but I am only storing two elements. Suppose this is array A. Now I am storing only 2 elements in this array. Suppose 7 and 3. Suppose I am storing. Then see, then these 3 spaces are empty. So now if you want to store the elements present at, suppose you are taking another array B and these spaces are empty. Now you want to store the elements, other elements into this array, into this empty spaces. So you can't do, because this is memory, this is the memory wastage in this. So memory utilization is poor in array, whereas it is good in linked list. Now so this is poor. Now let's say in linked list, see, suppose you have a linked list. Now I am suppose for this, no, in array we have declared the size initially at starting, like 5 is the size we have declared initially, but in linked list no need to fix the size at starting. See, how to add an element means, suppose see, now first element is 7, suppose I am storing 7. Now I'll take a pointer called temp. Now temp will point towards the head is pointing towards 100, so temp is also 100. So this points towards this. Now see, now the pointer towards this next node is 0, because no node is there next. Now if you want to add another element into this linked list, means what you should do? You should create a new node. Now if you want to insert an element, suppose 3 into this, then I am inserting 3 over here, then here 0, because no node is present next. Now you should store this thing. See, now this address this pointer, you should point towards the second node. So suppose let's say this address is 200, so you should store 200 over here. Now it points over this node. Now you should change the temp value to temp equals to temp next. So temp next is 200. So this points towards this thing. Now this value changes to 200. Now see, in this we no need to in this array we have initially declared the size of array, that is 5. But in this, if you want to add, no need to fix the size of linked list before itself. You can add one by one. So for this, no need to declare the size of linked list, so that the memory utilization is good and no wastage will be there. See, in this three spaces are wasted, but in this no wastage are there. So this is the difference between array and linked list on based off memory utilization. Now let's say memory requirement, this parameter. Let's see. Now see, you have 5 spaces in this array. Now let's say suppose 4 spaces, array of size 4, let's say. Now see, you are storing 4 elements into this array. Suppose let's say 7, 3, then 2, 5. Suppose this 4 elements I am storing into array. How much size it takes? Let's see. See, now there are 4 indexes, 0, 1, 2, 3. So 4 into data size. What is the data type in this array? That is, integers are stored into this array. Integer takes 4 bytes. So 4 size is 4. So 4 index into data size, that is 4. 4 into 4 is 16. So 16 bytes it takes to store this element into this array. Now let's see, so this takes 16 bytes in array. Same, suppose I am storing 4, now let's say there are 4 nodes in linked list. Now see, suppose same elements you are storing over this linked list also, 7, 3, 2, 5, 7, 3, then 2, 5. Now say, let's see, this is 300 address and this is, let's say, 400 the address. Now this points towards 300. Now this will point towards 400. So then this is 0 because no node is there next. So now see, now how much size this takes? Now this each node contains 2 parts, that is data part and pointer part. So this is an integer and this is also an integer. So this takes 4 bytes. And this also takes 4 bytes. So each node takes 4 into 2, that is 8 bytes. Now you have 4 nodes, each node takes 8 bytes. So 8 into, there are 4 indexes, I mean 4 nodes are present. So 8 into 4, 32. So see here, you are storing 4 elements into this array, it takes 16 bytes. But you are storing same 4 elements into linked list, but it takes 32 bytes. So the size is double. So let's say, so we can find memory requirement for array is less and memory requirement for linked list is more. That is, suppose if this takes n size, means this takes 2n. This is the difference. Now let's say searching. Now see, searching in array we can search, there are 2 types of searching techniques, that is linear search and binary search. Both linear and binary is possible in array, but in linked list only linear is possible, binary is not possible. Let's see how. See, what is linear? Linear search means, suppose this is the array of size 4. Now you want to search an element 2 in this array. 2 is present at second index. See, this is 2. So how to find? Linear search means it starts from 0th index, first in this base address. Now it search whether element 2 is present at this index 0. No. Then it moves towards 1. Now check whether 2 is present here at index 1. No. Now it moves next index. Now whether 2 is present at this index. Yeah, 2 is present here. So it returns that element. So in this array linear search is possible. It moves one by one. So linear search is possible. And if you see in linked list also linear search is possible. See, now how to find? Suppose you are searching 2 in this linked list. Now 2 is present at this address 300. How to find? See, now you will create a pointer called temp, and that temp points towards the base address, that is 100. It points towards head. Now see, you will check whether 2 is equals to temp data. Temp is 100, 100's data part is 7. No, it's not equal. Then you will change the temp value equals to temp next. Temp next is what? 100's next is 200. So this points towards 200. This value changes to 200. Now you will check 200's data. Temp's data is 3. Now 3 is not equals to 2. So you will move to next index, that is temp equals to temp next. 200's next is what? 300. So this pointer changes to this thing 300. So this will store here 300. Now you will check 300's data. Temp, you will check whether temp data equals to 2. Now 300 is temp. So 300's data is 2. So 2 equals to 2. So you have found. So in linked list you can move one by one using a temp pointer. So linear search is possible in linked list. Now let's see binary search. See, in binary search, one thing what you should for binary search or what you should do means you should find the middle index. Suppose let's say C. Suppose you have five elements present in this array. Suppose C. Let's say this address is 116. If you see in binary search, the elements should be sorted. That you will see in further. I'll teach you later. Now see, suppose 3, then 5, then 8, then 7, no 8, then 12, then 16. Suppose these elements are present in this array. Now you should use binary search operation to search an element. Suppose you want to search an element 12. 12 is present at third index. For this you should use one property, that is you should find the middle index. How to find middle index? That is base index, that is 0. Lowest index is 0 plus largest index, that is 4. 0 plus 4 by 2. So 4 by 2 is what? 2. Now so 2 is the middle value. For binary search you should use this step. So we are finding middle index by using this formula. Now in array this is possible because it is continuous. 0, 1, 2, 3, 4, like addresses are continuous in sequential manner. 100, 104 equal intervals is there. But in linked list there is not equal interval. Suppose this is 100, then this might be 300, this might be 700, this might be 200. Like I have written like 100, 200, 300 equal intervals, but this might not be equal. This might not be in equal intervals. Suppose this might be 100, then this might. In this case, you can't find the middle index. You can't find 100 plus 400 divided by 2. You can't do. If you find do like that, it will not find the middle index. So binary search is not possible in linked list. Now let's see inserting operation. Now see, inserting in array at beginning. Now see, now suppose the array, you have an array of size 5. You have an array of size 5. Now 4 elements are stored into this array. Now you want to insert an element at beginning. At beginning it means at first index you want to insert. How you can insert? Now the element present at last index is this 3. Index 3 is present. So for inserting at first index, how you should for inserting an element at beginning means you should move the element present at third index to fourth. Then you should move this element present at second index into third index. Then you should move element present at first index to second index. Then you should move this element present at 0th index to first index. After doing it, how it comes means see. Now this is empty. First space is empty. Now you can store. Suppose you want to store 8. Suppose you want to insert. Suppose let's say 7 in this beginning. Now this is empty. You can insert 7. So for this, how much time complexity it takes? For inserting at beginning, if n elements are present. Now in this case n is 4 because 4 elements are present. If now you should move 4 elements in forward direction, one step forward. So it takes O of n times for inserting at beginning. So at beginning means O of n in array. Whereas in linked list it takes O of 1. How? Let's see. See. Now suppose you have 3 nodes in this linked list. Now you should insert one extra node in the first index at beginning. Now what you should do? For this you should create a new node. You should create a empty new node. Now suppose you are inserting this 7 into this new node at beginning. So 7 gets stored over here. Now what you should do? Now you should store this base address is 100 at starting. This is 100 and this is 200. Now see, now this base address is 100. Now you should point this thing towards this thing, because now if you insert this at beginning, means this is the first node and this is the second node, so this should point towards this thing. So how to point this? At this place you should point 100. Address of this node is 100, so 100 should be the pointer of previous node. So I have pointed 100. Now see, now head is used to point towards the first node, but now if you insert this at beginning, means first node is this 7, the data 7 is the first element, so head should point towards this thing. Now head should point towards this thing, this node. So how to make head equals to new node? So now suppose let's say this address is 700, so this 700 gets stored over here. You have inserted this at beginning. So if you want to insert at beginning, no need to travel all the elements present in array. You no need to travel n times. In array you have traveled n times, but here you can do in single step. So the inserting at beginning in linked list is O of 1. Now let's say at end, if you want to insert an element at end in array, let's see. Suppose see, now you have 4 elements present in this. You have a array of size 5 and 4 elements are present in this array. Now you want to insert at last index. So if you know the length of this size of this array, size is 5. If you know the array of size, if you know the size of this array, then you can insert at you can insert at 5 minus 1, that is n minus 1. Size is n, means n minus 1th index you can insert. So it takes single step. So if you want to insert 7, means you can directly insert. You no need to travel one all the elements. So at the end in array means O of 1. If you want to insert an element at the end in array. Now in linked list means if you want to insert an element at end in linked list means O of n. How? Let's see. Suppose see. Now in this case, now let's say this is head. This is first node. Now head is pointing towards this first. Now 100 is the address of first node, so head pointers towards 100. Now see, now you want to insert at end. How you can insert? You should create a new node, empty new node. Now suppose you are inserting 7 at the end, so 7 I am storing here. Now 0 should be at the pointer part because no node is present next. Now see, now what you should do? Suppose let's say the address of this node is 400. Now see, now you want to create a link over here. Now see, in this case it was 0 at starting because this element was not present before. At that time this pointer was pointing towards 0 because no element was there forward. But now 400, the address of this node is 400. This node is present. So now you want to point towards this thing. So how you can point? This thing, address should be pointing to this address. 400 should be get stored over here. How you can store? You can't directly store. For that, what you should do is you should create a temp pointer, and that temp pointer points towards the first node. The address of first node is 100. So it points towards this thing. Now it moves towards second node, that is temp equals to temp next. 100's next is 200. So 200 gets stored over here. So this pointer points towards this thing, second node. Then again temp equals to temp next. Now 300 gets stored over here. Now so this pointer changes to this thing, like this. Then again next node, that is 400 is the next pointer. It points towards 400. So now next node 400. So like this. Now for that, if you want to insert means you should move one by one in forward direction. You want to travel all the elements from beginning to end. Then at this place, see, in the when you get temp equals to 300, see, you should move till temp next is not equals to 0. You should move till temp next equals to 0. See, in this case, at starting this was 0 because this was the last node. This is the new node. If this node is not present, means till this you should travel till temp next is 0. Now 300's next is 0. So till this you should travel. Then when the temp value is this thing 300, then you should change this temp value to temp next value, that is this 0 to this new node's address, that is 400. Now after this you should move, you should point towards this thing, it points towards this thing, then you should move this temp value to this thing. So temp equals to temp next, temp was 300, so 300 next is 400, so this changed to 400. So for inserting an element at linked list at end means it takes O of n because you are traveling n elements, all the elements from beginning till last, so it takes O of n. That's all for today and thank you. If you feel my teaching is good, then like my video, and if you have any doubts or if you want to give any suggestion, then comment on my video and share my video, and don't forget to subscribe my video. Thank you.